Hello everyone, and thanks for joining us for a new episode of OpenInfra Live. OpenInfra Live is the Open Infrastructure Foundation's weekly live show, airing every Thursday at 14 UTC. One recurring episode on the show has been the Large Scale OpenStack show, organized by the OpenStack Large Scale SIG. We invite operators of large-scale deployments and get them to present how they solve a given operations challenge and discuss live between themselves their different approaches. For today's episode, we decided to discuss Neutron scaling best practices. I meet with lots of new OpenStack users, and as they grow their deployment, scaling Neutron is a top concern. So for this episode, we invited developers and operators to explore early architectural choices you can make, recommended drivers, features to avoid, if your ultimate goal is to scale to a very large deployment. Our guests today are Ibrahim Derraz, Site Reliability Engineer at Exaion, who will drive the discussion, David Comay, Senior Cloud Engineer at Bloomberg, a very long time OpenStack user, Lajos Katona, Master Developer at Ericsson and current OpenStack Neutron project team lead, Sławomir Kapłoński, Principal Software Engineer at Red Hat and previous Neutron PTL, Michal Nasiadka, Senior Technical Lead at StackHPC and Cola Ansible project team lead, and the man who needs no introduction, Mohammed Naser, CEO at VEXXHOST and OpenStack Technical Committee member. As I mentioned, this is a live show and we will be saving time at the end of the episode for Q&A. So feel free to drop your questions into the comments section throughout the show and we'll try to answer as many as we can. I'll now pass the mic to Ibrahim, who has plenty of questions for our panel. So take it away, Ibrahim.
Hi, everyone. So as Thierry introduced me, we are Exaion, a new user in the OpenInfra Foundation. We deployed OpenStack in our infrastructure, but we are mainly new users. As we grew up, we had some questions about Neutron, how to scale with Neutron. So this is the episode of today. So as you know, a Neutron is a pretty complex subject in OpenStack. It's pretty hard to scale the network in general. We had a lot of questions that we asked to the OpenInfra Foundation. And I thank everyone to be here to answer all our questions and the community of course. So the first part we had question on is the driver part. So what are the drivers or plugin we will recommend if we want to reach large scale? I don't know if anyone wants to begin now or if we introduce ourselves first.
I think given that Thierry has done a great job giving us all a small intro, maybe we can get to diving into this first question. And I guess I can start. So for me, at least, I find that we run the OVS driver out of the box, which is kind of just the Open vSwitch, which has kind of, I think, been the de facto for OpenStack deployments across the years. There's been some recent changes that maybe some other people here that can talk about with kind of more of an OVN based thing. But for us, OVS has been the thing that's kind of reliably and kind of always worked in terms of a driver. And so I would say, that goes back to ML2 and really what I think is what a lot of people are running is the ML2 driver, and then whatever agent that you use in there in combination.
Thanks, Mohammed. So I think I can share my thoughts from the developer point of view. So basically, and from my experience previously as operator also, there is no one single and the best for everyone answer which driver scales the best. Basically, each of them will more or less scale well if you will configure it properly. Each of them will require some tuning, some fine tuning to do. As Mohammed said, ML2 OVS driver backend is basically was the default one in the dev stack, was the one which, and still is the one which is still which is used by most of the deployments. Now there is this OVN driver, which is a backend, which is I would say hot topic currently, and is new default in dev stack and in upstream CI, and we are putting a lot of effort in developing that, but still ML2 OVS can I think scale pretty well. Of course, there is also Linux Bridge backend, which is, I would say, simpler than ML2 OVS or OVN. Maybe don't have feature parity with OVS backend. So basically, there are things which can't be done in with Linux Bridge backend, but from the other hand, it's much simpler topology on the compute nodes, for example. So some people may be more familiar, and I know that there are deployments and there are big players who prefer to use Linux Bridge instead of ML2 OVS because of this simplicity, for example. So yeah, that's more or less what I wanted to share from developer point of view.
Yeah, perhaps I would like to highlight as well that that there is no single best recipe for choosing the best driver. So from maintenance perspective, which driver has the most attention? That's now for sure OVS and OVN. But yeah, we have other like Linux Bridge, which we still try to maintain, and there are users, as Slavek mentioned, who still work with Linux Bridge. Yeah, and then so there are even choices which perhaps the best now. For example, Ericsson still uses ODL in some deployments, but that's a kind of taste of choice, or how to say that. So there is no best recipe. So you have to consider what you need, how you can propose solutions if you find a bug, or you just want to use that and you have no development time to work on that and help the community to fix things if you find any issue with the driver which you choose.
I think I'll jump in here to say that for Bloomberg, we have used Linux bridging in the past with Nova Network and Mitaka. We currently have moved to Asuri-based OpenStack, and so when we did do the jump, we switched to using Calico. So Calico, which is currently sort of, I guess you call it an out-of-tree driver, out-of-tree implementation, which is unfortunate, and hopefully that can be fixed in the future, is a pure L3 solution. So we don't have, in our case, we're not using any sort of underlays or overlay. Everything is L3. So our hypervisors basically are talking to traditional leaf spine architecture, a pair of TORs, and we're using BGP to announce the routes for the VMs. We're able to support things like floating IPs as well, but what we found was, moving away from everyone using floating IPs to having sort of overall connectivity has been a real plus, because we've just basically eliminated one source of certainly user confusion, but also just strangeness in the networking stacks where, for example, two hypervisors are both responding to ARP requests for the same host and things like that. So that's another alternative that we've found very, very helpful.
Perfect for that part. So during this conversation, we heard a lot about OVS and OVN and the part with Calico from Bloomberg. I want to go more specifically in the choice between these two major parts, so OVS and OVN. I know that there were like features. It went not. There is not a feature parity between both. For example, the VPN as a service that was missing in OVN and that was introduced with Xena. Do you know other part that, for example, we can say you shouldn't go with OVN if you need this feature, or this feature will be implemented soon, or don't use, for example, the VPN as a service, for example, with OVN right now because there is missing features part, missing technologies. Do you have any feedback on that? Some users or clients that reported some features incoherence between OVS and OVN?
Yeah, actually, there is a page in in Neutron documentation about the gaps between OVN and OVS. So that's checked quite frequently when something new is merged to OVN, which covers features in OVS. Yeah, but actually, so if you need special drivers like BGP or VPN, that's always hard. So next week we will have the PTG and we will have discussions around, for example, BGP and BGP VPN covering from OVN. So yeah, some features are not in OVN actually, but if I understand well, mostly from Red Hat side, there's quite an effort to have those filled in. But that has to be checked first. If you have some special need like a VPN and which driver is the perfect for you.
Yeah, I find that, even though OVN is not something that we use on our side, I found that the fact that it's kind of built up to be a network SDN from out of the box, that's kind of what it's meant to be. So Neutron becomes more of a, the way that I see it with OVN, Neutron is more of a OpenStack Nova, and OVN is like libvirt and KVM and all the fancy stuff happened there. Whereas the current like Neutron OVS, it's kind of a mishmash of like Neutron does some data plane management and kind of goes back and forth. So I think I personally like the OVN. There's also other advantages like, there's an OVN Octavia driver. So for example, you can do load balancing a lot more effectively without having virtual machines that are running your load balancers with HA proxy instances. They're just simply using OVN to kind of build load balancers natively using OpenStack.
But it's also important to note that the Octavia OVN driver only supports TCP and UDP load balancing, right? Health checks have been added, I think, recently. So if you need something more advanced than TCP, right, then probably it's not the driver you should choose. Coming back to gaps in OVN, I think one of the, at least most important for us, is that OVN DHCP does not work for bare metal ports. So there's a workaround to use the Neutron DHCP agent, which we are using, but we're looking forward to get rid of that, if that's possible in a couple of next cycles.
Yeah, so there are some gaps, as was already said, but the list of the gaps is becoming smaller and smaller every cycle. So we are really hard working on that. Except what was already mentioned with bare metal provisioning, with BGP and VPN things. The biggest, I think, gaps which are still on the list are related to quality of service. So if you need DHCP marking or QoS for layer 3, like gateway for gateways, then that's also something what is not supported in OVN yet. But as I said, we are working on it. We are moving forward, closing those gaps every cycle. Now OVN is default backend used in the dev stack, so it's, I would say, the well-tested backend because it's tested by all jobs used in Tempest, Glance, Nova, and every other project basically in the upstream community. But from the other hand, I want to add one more thing that chose how to choose between OVN and OVS backend. Again, it may depend on what you really need, because ML2 OVS, from the other hand, is using some well-known technologies like I don't know, Linux namespaces, IP tables, keep alive D, DNS mask, and things which all of us are probably very familiar with, and when it will become when we will need to troubleshoot some problem on the production, it's much easier to do it with ML2 OVS than with ML2 OVN and looking into the hundreds or thousands of OpenFlow rules and understand it. So OVN is, I would say, something what will be better for the future, but currently I can understand people who will choose OVS just because of it's easier to troubleshoot and to understand what's going on underneath. And so that's my point of it.
Okay, perfect. Now I want to ask a question about resilience. So we have chosen our SDN, OVS or OVN, like explained by everyone here. There is a resilience part to make sure that nothing goes down, to make sure customers can access to the services, and etc. So there is a lot of work done on Neutron, for example, with VRRP, DVR. What are for you in the physical part also, and on the software part, the most resilient choice to make sure that we can guarantee that if, for example, a node goes down, the service goes down, something else will take the relay and make sure that no services will be impacted by this down.
I can start talking a little bit about this one. So for us, I guess the way that we manage, one of the ways that we try to help our customers try to be as resilient as possible is we ask them to. So what we allow customers is to directly plug into the public network, and I think that for a lot of scenarios that gives you a lot of advantages if floating IPs is not something that is kind of a big deal for you. Because most of the time, if you're doing something like ML2 OVS, to get a floating IP, you need to have a router. And then at that point, the router could be using Keep Alive so that it's actually active backup. But there is still a time that of failover, and you're kind of hairpinning through your network nodes. So you're bringing all this traffic through systems. And if you're just mostly doing it only to get a floating IP and you don't actually need to reuse this IP address, you're going through an extra layer for not a very big advantage. And so one of the things that we like to tell our customers is we allow them to plug directly to the public network, which means all of our compute nodes are also directly connected to the public network. And so by doing that, we're eliminating the entire kind of SDN path and having the user just be connected directly to the switches that go to the gateway, and this all physical hardware. So it's no different than having a physical system that's connected to a switch at that point. So we find that has a tremendous improvement, because if there's any outage of the networking control plane or the routers or one of the controllers, you're completely unaffected by this at all. As long as the compute node is still running and operating, you have no issues. So that's something that we kind of find is like the combination of, use L3HA and Neutron to try and make sure your routers are highly available if you have to use, that. Otherwise, just plug directly to the public network. So we know that path is, pretty stable and not going through, Rabbit or database or upgrades or anything like that.
anyone else wants to comment on that, the most resilient choice? I think I have seen on some posts that with OVN, for example, DVR and VRRP had some trouble at some point mixed together or something like this. I don't know if one of the Neutron PTL have some feedback on this, on is it possible to mix all these resilient choice together? Is it possible? Is it recommended also? Is it not? Perhaps I'm wrong on that, but I think perhaps you have the answer to my question.
Yeah, I just wanted to mention that, for example, Ericsson customers usually skip the whole virtual layer 3 stuff. So they have their own network fabric, and OpenStack just gives the layer 2 connectivity, and everything else over that is handled by some other routing and the gateway fabric, which is out of OpenStack control, or they have some special drivers for that. I don't know exactly, but that's another option if you need that, because in that case that part is not affected by upgrades or issues with the network node or with the controller, as Mohammed said.
Getting back to your question about OVN, in the OVN case, traffic is by default layer 3 traffic is by default distributed, so you have kind of DVR enabled by default, and traffic which is using floating IPs will go to the external network directly from your compute. Of course, SNAT traffic is still centralized on one of the nodes, is going through one of the nodes. So this is kind of similar to what ML2 OVS with DVR is doing. And with ML2 OVN, you asked about VRRP traffic, but in the Neutron is not using VRRP at all when ML2 OVN is used. So maybe I'm not sure exactly what issue you were asking about, but
I think I missed between OVS and OVN. I think it was on OVS. Sorry.
I was just going to say, from with our Calico implementation, so for resiliency, we tend to, as I think I mentioned earlier, each of our hypervisors has effectively a pair of TORs that it talks to in the rack. And so we effectively use ECMP, or we implement ECMP that way, so that if one of the TORs, for example, fails, we have an alternate path. Those TORs themselves are connected to a set of spine routers, and then even above that we have a set of super spine routers, and so on. So that tends to be how we have resiliency at the lower level towards the VM side. Okay,
thank you very much for that. Another key part of the resiliency of our network infrastructure is the features to be enabled or not. We want mainly to use the VPN as a service, for example, but with our experience, we don't know yet how does it affect the network at a really large scale. We don't know if, for example, we have 50 users. For the moment, it will go okay, but if we have 1,000 users, we don't know how it will react. Do you have some feedbacks on some features to enable or stay away from when we are trying to achieving large scale on OpenStack?
Yeah, so basically, short answer is that if you want to go with large scale, you should enable as few features as is needed. Basically, more features you enable, more troubles you will have, I would say. So please enable what you really need. Basically, What I'm talking about is, for example, let's talk about L3 agent. If you enable, I don't know, floating IP port forwarding, if you enable some QoS things and some other extensions and plugins there, everything will work fine unless you, for example, restart your agent, and it will have to reconfigure everything from scratch for 1,000 routers which are on this compute node. It will be okay, but it will take more time when you will have more extensions enabled, right? Because each of them will need to configure some IP table rules, some TC rules for QoS, or something else. So basically, less you will enable, easier it will be to get to large scale, I would say.
And in that situation, probably it would be good to mention that it will put a lot of strain on the Neutron server API and the massive cost, right?
Yeah, that's also true.
Thank you for that. So I think we've answered all the questions from the architectural part. So software, and we didn't talk a lot about physical routing, except on the Bloomberg side that saying they're using some spine leaf architecture with a super spine leaf routers on top to ensure the most resilience part. On the Red Hat side, or Ericsson, VEXXHOST, StackHPC, on the physical parts, I know that there is a lot of use cases, but what is for the new users, if they want to achieve some kind of resiliency on the physical part, what will be the easy road to get to achieve that hardware?
I can start a little bit. Yeah, I think for us, I mean, the way that we build out any kind of cloud or anything is we use spine leaf architecture. So really making sure that you're building your network to be layer 3 out of the box really helps you a lot down the line. Now the nice thing these days is that back then, switches that can do layer 3 were a very expensive, very inaccessible thing. Now I'd say most switches that you're going to get are going to be able to do layer 3, are going to be able to run BGP, are going to be able to run most routing services. So generally we have, spines and leaves, where what we do is we have 2 leaves in every rack, and every leaf is connected to both other spines. So that means that every single rack has 4, connections going to it from 2 different spines at least, which really, and they're 100 gig links. So every rack has around 400 gigs a second that's coming in, and it's all fully redundant. And those switches are set up in an MLAG or CLAG or whatever your vendor calls aggregation of switches. And so by doing that, then, every system gets a link from each one of those. So your entire network stack at that point is all pretty reliable. Now, where we go a little bit further is a lot of people, when they deploy provider networks, they use VLAN for provider networks. What we've done actually is we use flat networks, but what we actually do is we run BGP inside all of our compute nodes. For the folks that use Calico, this is going to sound very Calico-y, but we run BGP on every compute node. And what we do is we have a VXLAN for our provider networks. And a big part of that is because all of our routing infrastructure is also all Linux-based. So everything is using VXLAN. So we don't have any problems with having one network with, 100/22s. That's not a problem because there's no ARP that goes out anyways. All of the MAC addresses are all being published by BGP. And so what we have is our compute nodes all talk to the top of rack switches, which every rack has its own BGP AS number, so that it just not naturally does eBGP to all the other racks. And so it's super effective. It cuts down on traffic that is just like ARP traffic. And it's also really reliable and nice because if we want to spin up a compute node for a customer in like another room in our facilities, we don't have to go and run cables or whatever. As long as it joins over layer 3 in some way, has reachability, it can get the VXLAN network published, and it can start, talking over that network. So that last part is where I feel like we're a little bit kind of, you got to do it right, or otherwise you might have some weird stuff come up. But I'd say kind of the layer 3 MLAG is kind of the way to go, in my opinion.
Perfect. Thanks for the answer. Oh, perhaps Lajos, you.
Actually, I have just a question. So you don't you use BGP VPN or Neutron dynamic routing for this, or it's something not managed by
so
Neutron?
it's not managed. So we use BGP EVPN to propagate all this stuff, and so it's not managed by Neutron. What we do is we present the physical interface, and then we attach that physical interface to OVS. So for all that OVS knows, it's just a thing that's bridged to BREX.
Okay.
There is a little tricky thing that we have to do, because FRR, free range routing, cannot read the MAC addresses and publish them off of OVS. So we have to create a Linux bridge and then set up a virtual Ethernet and plug one to the OVS and one to the original bridge. And we're hoping that with time, OVS or FRR can natively learn MAC addresses from OVS and publish those out.
Thanks.
Thanks. So now that we have, now that you have answered all our architectural questions, I would say, performance-wise, we had some question at one point that we're using SDN, but perhaps sometimes SDN can be helped with some hardware card, for example. We wanted to leverage some of the decapsulation and encapsulation of packets with some smart NICs. So do you already installed smart NICs and use hardware offloading with OVS, OVN? Was it helpful? Yes. Or didn't help at all and just stayed with software defined? Perfect.
So we've been using Mellanox ConnectX cards, mainly ConnectX 5 and 6. 6 are nicer because they can also offload connection tracking. So security groups and all that stuff works fine in hardware. So we've been able to reach near wire at the Ethernet speeds. Well, you're talking like 50 gigs, 100 gigs, and so on, right? So that's nice. That is mainly working for us on MO2 OVS. In the OVN installations, if we're not having ConnectX 6, which offloads connection tracking, then we need to disable port security or use stateless firewall that has been introduced in latest OVN versions and so on, right? So there's a lot of considerations if hardware offloading will really help you to do the job or not, right?
Okay.
I actually have a question. So we did dabble a bit with the ConnectX 5 and 6s, and I guess a question that's maybe related to what Ibrahim is also mentioning is, how much tuning did you have to do on the compute side, right? Because it's one thing that it has the ability to offload 25 gigs, but I think a lot of times when we were trying our experiences, it was a lot of changing, maybe, I don't know, IO threads and all sorts of other tuning that you have to do to the virtual machine so that it can actually push that sort of traffic, or if it has enough vCPUs. What was your experience like with that?
I think perhaps my Michael?
Michael, did you hear that last bit that I mentioned?
Yeah, it was a bit choppy. Probably my internet.
I'll quickly brief. Yeah. So I was saying, I'm sure you had to do a lot of virtualization tunings for Nova so that libvirt launches VMs with some specific options or whatever. How much time did you spend on that? And is there anything that you would kind of point at and say, these are some important stuff to give you a big boost, and even if you're hardware offloading?
Yeah, so we've been doing some of that stuff, also doing some patches to Neutron or Nova. At least some of my team members have been doing that. So probably it's a very long topic. So as I said, it's not really trivial to set that up. We've spent considerable amount of time on doing that, right? There's a lot of blog posts on the StackHPC website pointing to what we've done, right? So I don't want to really talk for the next 15 minutes. But yes, as I said, it's really not trivial, right? We've spent very long days, sometimes weeks, to get that working as we'd like to get it working, right? And in most cases, we've been using that so we're using ASAP Square and the VFLAG functionality for SRIOV, right? So that also adds some resiliency. So we're using a bond for the SRIOV networking, but yes, it's not very easy, and in most cases, it also required some interaction with the vendor, right?
Yeah. So I think the kind of good takeaway from this is I think hardware offloading is great. You can hit really high speeds, but it's not a buy it, install it, change the config, and now you're getting 50 gigabits a second from your VMs.
Yes, unfortunately, it's not that easy, and we would like to be that easy, right?
It would be very nice.
Thanks, Michael, for that feedback. I think it's really interesting. We will ask some question internally, I think, for us to install that those hardware offloadings. I think it will be really interesting. Another question we had in Exaion part was how to size our network nodes in order to not hit some limits. So for the moment, we don't have enough experience on that side. How many nodes, network nodes, should we have? How many CPUs how many CPU cores we should have on them? How many RAMs? Is CPU is an important factor if you want to only do SDN for the decapsulation part. Do you have a method for all of us to know how many nodes do you need for a specific part, or do you just, you monitor everything, and when you see that it begins to hit the limit, you add another node or something like this?
So maybe I will start answering this question. First of all, we have two factors here, I would say. First is scaling because of the data plane and because of the number of resources in Neutron. And the second thing is scaling because of the data plane, how much traffic you want to send and so on. And I would like to talk first about this data plane and resources, Neutron resources thing. So basically Neutron, I would say, scales pretty well horizontally, but it won't scale vertically. Agents, when speaking about ML2 OVS, right, and L3 agent, DHCP agent, the agents are basically single thread applications, and if you will have, no matter if you will have 32 cores or 1 or 2 cores in your system, it will configure everything more or less one by one, and it will spend the same amount of time. And now the second thing is that there is when everything is up and running fine, then it's running fine. You can have, for example, 100 routers or 1,000 of networks in the DHCP agent, and all will be fine. The problem will happen when you will have some you will need to restart this agent when you will have some problem with RPC messages and some timeout in RPC messages in the agent, because such operations will start full sync of everything, and then agent will have to go through everything and configure everything again from scratch, and this may take a long time actually. So because of that, it's better to have, for example, more nodes with DHCP agents or L3 agent, and keep less number of routers of networks on each node, rather than have huge network node which will host everything for you, because basically you will have easier maintenance later. So that's my advice to scale horizontally, basically. And the same is for API workers. You can have as many API workers or RPC workers as you want, and this should work pretty well. So scaling that way is, I think, better in terms of data plane. Control plane and number of resources.
Okay, perfect. Thank you, Slavik. So for the performance side, I think we are okay. I don't have any more questions. But now I have more a question about how do you run Neutron production, the monitoring part, the command downsides and failure. So the main question that we have is, so like I said, what are the common and common downsides failure of Neutron? What do you have encountered, and what critical metrics did you monitor to see that everything was going down, or and how did you act with this failure or downside?
I can start this up. So we got a couple things that we actually watch for when we're monitoring clouds, and especially how to know if Neutron is doing the right thing or whatnot. So a couple things that are, I'll start with what kind of comes to my mind at first, right? One of the things that is actually pretty interesting, monitoring your availabilities of subnets. You don't want to find out the day that your IP is completely run out, especially if you're working with public IP space, for example. So monitoring things, just making sure that you could still have enough IP addressing in your cloud. Another thing that we like to monitor is checking the binding status of Neutron ports. So sometimes if there's problems that start happening, you'll see a lot of Neutron ports going into binding fail status. Usually that's a telltale that there's something not okay that's happening that will require a little bit more investigating as well. A lot of times, if the OVS agent is up, then things are probably, whatever agent you're using, reports up. Things are usually means that they're working, but that doesn't necessarily tell the whole story. Sometimes an agent can report that it's up, but it's having problems communicating, or maybe sometimes what happens is some race condition occurred and a bunch of IP tables rules came in a misorder. And now Neutron is just looping, trying to save the IP tables rules, but it's failing to save them. So being really mindful at looking for error or trace level of mistakes, exceptions in the logs is super important and can really uncover a lot of things. And I think this goes for a lot of OpenStack projects, but the health of your RabbitMQ cluster is like super critical to the health of everything. When things are not good in RabbitMQ, not only could they cause problems like at the time that they are, but they can start to introduce corner and edge cases that are just not considered, right? So what could happen is if your Rabbit is acting up, a bunch of ports that might be half provisioned because the messages are not being fully delivered. So you end up with things that are not clean, and then the recovery becomes even more difficult. If anything, I would be, if you're trying to kind of get out of a failure when Neutron or anything, I would be more in favor of completely shutting down RabbitMQ if you have suspicions that it's causing problems, than trying small little things here and there, because in my experience, the longer the outage goes, the more edge cases you're starting to enter, and you're going to end up with weird stuff in the cloud. Small other things also, if you use L3HA, OpenStack, well, Neutron has a great API to tell you which router is active and which one is backup. Sometimes you'll see issues where all of them are backup. Sometimes you'll see issues where more than one is active. So those could be telltales of like, okay, there's probably a networking issue that we need to look into. Those are some of the stuff, other than that I said that are a bit more like very specific and in the weeds. Obviously, you've got the normal, make sure services are running, make sure agents are up, make sure the API is responding sort of thing as well.
Yeah, I'll just mention that I think we see very much the same sort of issues and so on. Rabbit is very essential to everything, but for example, with Calico uses etcd for basically storing both policy, which actually the firewall policy it actually instantiates on the compute nodes, as well as information about networks and subnets. So if etcd is not healthy, that's an issue with respect to Calico. So you trade off, one thing. So Rabbit doesn't necessarily affect Neutron as much in our implementation, but we have another thing that is another failure point. The other thing we've seen in the past is cases where we DNS mass queue on our compute nodes. They're provisioned through the Calico's DHCP agent, and sometimes DNS mass queue didn't get updated for new tap interfaces has been instantiated. And so you'd get VMs that get created, but basically there's no DHCP responses and so on. So we've had to, take a look at, things like, is the running DNS mass queue process, does it know about all the tap interfaces it's supposed to have? There have been some bug fixes recently in Calico to address some of those things that, where things get missed at scale. There's so many VMs being created and so many interfaces being, so many ports being created that a message can basically mean that you get, one VM out of 100 that is there but not pingable and so on. Internally, we have some internal metering, but we also use Telegraph, Influx's Telegraph to, send a lot of data back and do monitoring that way.
Okay.
One quick thing, if I may add to what Mohammed said actually about putting everything down when everything goes crazy and then starting it up. Please don't, if you have large scale and, for example, a lot of routers, a lot of networks in DHCP, don't restart everything at once. Do it one by one or in batches, because otherwise you will have like denial of service on Neutron server, because everything will ask for all networks or routers and all other data. And then Neutron server will basically do some DOS attack on the DB and everything will go crazy, and it will be still like snowball effect, and you will have all the time problems. So please do it in the batches or in small batches or one by one, and then it should be easier to recover in such a situation.
Yeah, and I would just quickly add, like, patience, I feel, is a really important thing sometimes. You just got to let things take their time, start up, make sure it's stable, then move on. In an outage, people are like, oh, let's go. But then just like, you might cause more interesting problems.
Okay, thank you for all the answers. It's been really interesting. I have just a small questions, especially for Mohammed and David. Do you have a dedicated network team for your production on your side that's managing everything, make sure that Neutron is running, or do you have more an overall team that's managing everything?
In our case, we don't have a dedicated team. I think the responsibility is split. There's an operations team that would be focused on the actual network, the switches, the routers, and so on. There's our team, which is more looking at the cloud pieces, and we do look at, for example, the status of Bird, which is the Bird implementation, the BGP implementation we're running on the hypervisors that are talking to the pair of TORs. And then we also have a network policy firewall team that is actually pushing policy into the compute nodes effectively. So that division is sort of split between those three. So if we have an issue, often we have to sort of figure out, okay, is this something that's a physical issue? Is there a spine that's down that's causing some sort of issue? Or does it seem to be a policy issue, in which case then we go to the firewall team, try to find out, was there a bad policy pushed, for example?
And on our side, no, it's really the same team that kind of focuses on the same, and that's mainly because a lot of our, like I said, our networking stack is all Linux based, so it's a lot of the same tooling that we're interacting with, whether it's compute nodes, routers, switches, all kind of run the same thing.
Perfect. Thank you. I think I have finished with all my questions. Thank you all for asking. I think Thierry can get the microphone for the Q&A.
Yes, we had plenty of good questions in the chat. We'll present two of them and see if you have good answers for them. So the first one is from Bassem on the YouTube chat, and it's how is your experience with centralized routing in Neutron, like where all the traffic goes to a Neutron server for a large scale OpenStack environment? Who wants to take it? Does anyone use centralized routing?
Yeah, I mean, we run our virtual routers on a bunch of systems, and we don't use DVR. One of the big reasons why we don't use DVR, at least back then, was the fact that it consumes a public IP address for every compute node. And as you get large scale, that adds up to a lot of IP space that's being used for, potentially one single system or one VM that's running somewhere. So that just doesn't kind of work out for us in that sort of scenario. So we kind of do that, but we don't have too many problems, like I said, because we try and push customers to be directly connected. So whatever the leftover traffic across centralized routing works pretty well. The only caveat usually is startup time for Neutron L3 agents can take a little bit of a while as it goes and rewires and reinstalls all the routers, and that can take a little bit of time and goes back to the comment around patience.
I can just say that recently in one of our customers' deployment, we noticed some issue when there was a lot of, hundreds of routers, HA routers. So there was a lot of HA VRRP traffic sent between them. And when one of the nodes went down, keep alive D was starting sending VRRP packets and on other nodes. And there were problems. Basically, OVS was consuming a lot of CPU and everything was basically going crazy. And the only way to recover everything was to shut down and start network nodes one by one again. But that's, again, something what I already said. If you scale, if you have large scale, you should have more network nodes and scale horizontally. Then if there will be so many routers hosted on one node, it should be better. So
thanks for your answers. We have another, unless someone wants to add something to this, but I can't see if you're, raise your hand if you have more. The next question is from Seong-Soo Cho from Korea. And the question is very specific. The time to restart the vSwitch agent can become longer in DVR with hundreds of hypervisors. His guess is that the agent is looking up a lot of ports from the database while restarting. Is there a way to solve this?
So maybe I will answer because it seems like more code-oriented question. So the way how it works is that it's not only because of DVR. Every time vSwitch agent is restarted, it will ask for Neutron server for details about each port. what is different with DVR and what can be the root cause here is that with DVR you have to enable L2 population, and basically every time ports are updated, Neutron server will, and they are updated because vSwitch agent, when it's restarted and asks for details about port, the port is updated, state of the port is updated to be down or active or built, and because of that, because of that port update, Neutron server will basically notify all other agents that FDB entry for this port was changed. So because of this L2 population, there is a lot of traffic and a lot of RPC messages sent to all other OVS agents on other compute nodes where there are ports from the same Neutron network, basically. And probably because of that, this restart takes much longer time in case of DVR. If there are any way to solve this, I don't think so, to be honest, for now. I don't remember about any work in the upstream to improve that. I mean, we did some improvements with FDB add and FDB remove and this L2 population mechanism in last cycle or 2 cycles ago or something like that. So maybe if you will update your Neutron, maybe it will be better. I don't know exactly what version is used there, but there is nothing else what we can do with that, actually.
Yeah, as I remember, we had some bug fixes for improving how OVS agent discuss these things and refresh these informations from Neutron server. But that was not specific for DVR. It was just how these RPC things are working. But there were improvements in the last cycles perhaps. So it's worth to follow Neutron and OpenStack and have as latest version as possible.
Okay, well, thanks everyone for answering all of those questions. I think it's time for us to close this episode. I think it was really a great way of demystifying Neutron choices, and I hope the audience learned a lot from this discussion. I certainly learned a lot, so that's great. So a few other news that coming up next weeks and in the near future. First, if you are an open infrastructure user, tomorrow is the deadline for nominating your organization for the 2021 Super User Awards. So you can see the URL on this slide. If you want to nominate your organization or someone else, please do so. And the deadline is tomorrow, so not much time left. Next week, we will not have an OpenInfra Live episode because we have our Projects Team Gathering event happening all week. The Project Teams Gathering is where our project teams get together to discuss and organize the work of the upcoming month of development. So it's a very key moment in our development cycles for OpenStack, but also for all of the other open infrastructure projects. This one is happening virtually. So anyone can join for free, and there is still time for you to register to attend that event at openstack.org/PTG. This event is really made possible with the support of the Open Infrastructure Foundation companies. So thanks to them for supporting the development of open infrastructure. And if you're interested in joining the foundation, please head to openinfra.dev/join. Our OpenInfra Live show will be back the week after. But also note that we'll have a very special 2-day episode with keynotes next month on November 17 and November 18. So this will replace the traditional keynotes we have at Open Infrastructure Summits. It's free and you really don't want to miss it. So don't forget to register for this very special event. Registration is open at openinfra.live. A special thank you to Red Hat, our headline sponsor, and Hivolve, InMotion Hosting, Carrez, ComponentSoft, and Cloud and Heat, our supporting sponsors. And finally, don't forget that this show is for all the open infrastructure community. So if you have an idea for a future episode, we want to hear from you. You can submit your ideas at ideas.openinfra.live. So thank you all for joining. See you again in 2 weeks on Thursday at 14 UTC. And thanks again to all of our speakers who joined us today. And special thanks to Ibrahim Derraz for leading this session. And see you soon on OpenInfra Live.